Hey, okay, yeah, fix the microphone. It seems to have gotten disconnected after a while. So let me turn the music down. Good evening. Welcome to the pre-show, as we call it. Where, come on, stupid voltage, the stupid slider doesn't want to slide. There. Where we fix the audio levels and we fix the things we forgot to turn on, like this guy. There. Good evening. I'll read your names in a second, but we need to figure out something fun for the background there. Bouncing balls, is that fun? Sure, and we'll do it in temperature. Does that do anything? Yeah, it does. Okay. I guess I just need to turn the brightness down a bit. There. What FPS are we getting? 200 average FPS. That should be sufficient. Are you load testing with an hydraulic press or a bench power supply today? Neither. Well, okay, we'll use the bench power supply for some stuff, but for most of it we won't. We're 60 FPSing. That's good. So we're going to use real power supplies today because even the upgraded bench power supply is only capable of 30 amps. And where we're going, we're going to need more than 30 amps, baby. No. So, yeah. Let's see who's all here. Thomas Orzakowski, 7, says, fireworks. Maybe. Oh, maybe. We'll see. If I did, like, really stupid things in the design, yes. And Jade Anderson says, oh no, the video title. I hope you can change it retroactively. I also noticed right before the stream, so I have changed it, but it can take a while to propagate, so we'll see. And then Nigel.Tech says, hi, looks like we are doing some testing tonight. Oh yes. And Thomas Orzakowski's, yes we are. Magic Smoke says Red Dog. We'll see, maybe. We could blow some fuses. So glad to have made it. Been a long time, says Tim Mason. Well, hi there. And Medved is here. Good evening. No sound. Well, that's fixed. Hey, Quinn, Foxionaire, and Christian Kvisk. Hello. All? Well, hello. Nix and TS Productions. Okay, yeah, I think I got most of people. Oh, and then the LED. The LED scientist. That sounds ominous. Evening Quinder, looking forward to another video question. You did a video about RGBW puck lights. I want soffit lights 24 volt, obviously used with the quad. Which can you advise in or out of tracks? Look up the video I did about the RGB CCT WS2005 pucks. Those are very nice. I like those a lot. So you'll have dual whites and all the colors and stuff, and a good PWM, and yeah, those I like those pucks, and you can use them bare or in a track. So yeah, maybe look at those. May the smoke be with us, says Slizer. Okay. Umakavala is here. What are we drinking? We are drinking. Oh, it's Emil. Okay. Hello, Emil. Today we are drinking 2 cans. We have Coca-Cola Zero Sugar Cherry and Fanta Zero Sugar Lemon. We're going to start with the Coke because, I don't know. Rather drink it sooner than later in the evening. Yeah. Mr. Tech Gadget, welcome to the live stream. Curious to the new prototypes. Have you shared specs changes yet, or will that come today as we go? That will come today as we go, because these are the latest prototypes. I received them this week. And they are now feature complete, and I'm pretty sure they're basically done. There are some engineering, or rather manufacturing challenges I still need to solve, where things are basically too hard to manufacture for a decent price. But yeah, basically they're done, so we'll talk about the features and stuff like that. May we be upwind of smoke should it be released. Hey, we can always blow a fuse. You have a nice gemeentepils. Okay. Greg Cressy, thanks Quinder for the ad. Greatly appreciate. Also Malachi. Oh, hey there. Malachi says hi. He loves your videos. We watch them as part of father-son time. Aw, that's really cool. Oh wait, I'm on the desk view. There. More new products really need AllNet to offer a salary sacrifice scheme. These are not so much new products, but updated products. I'm also working on some other updated products. The last few months have been in the light of upgrades. So I like to upgrade the boards when I can, when it makes sense financially and feature-wise, and maybe stuff I learned how to improve or how to do it better. So the Dig Uno, for instance, where's a Dig Uno? Here we have a Dig Uno. This is now already version 4, so it keeps the same name. It just keeps improving, right? So that's the idea. But we'll take a better look at those today. So there will also be no secret today, because the whole stream is secret. You saw number 43 today with a couple of dropouts. Was quite funny. You mean where we did the hot plate and I kept blowing the circuit, or? Soul Juice is here. Welcome. Poor, I can't answer that, Greg, mainly because I don't really know how a soffit is constructed. Because I'm in Europe, I'm in the Netherlands, and we don't have soffits like you have in the US, because our houses are constructed very differently. So, yeah. Anything in the board that had 4 RJ45 port, I think it was last time. I remember you had some issues with it. 4 RJ. Oh, you mean like the diff power sender? Diff power is still in development. Last prototypes were doing really well, but there's some edge cases I'd still like to rule out. So, yeah. Yeah, that one. Well, I don't know the number, but I know the stream where we kept blowing up the house circuit. But I looked at it, Emil, but I haven't really, or I saw it come in, but I haven't had the time to look at it well. So I'll try and do that. Hello from Finland. Hello there, Samir. Sure, that's cool. Nice, Greg. That's appreciated. Well, in theory, that was a different group, so I don't know. Yeah. In the new house, we'll do that differently. What do I want? Oh, right. I wanted to start with trying to get this blasted thing connected. So that always takes us about an hour. Okay, that's maybe exaggerated, but still, let's do that in the pre-stream so we can have thermal views. You're on the hunt for a new house. Well, I'll have one for sale where I live in a year or two. Yeah. Let's see, general settings, Wi-Fi. Who knows? Maybe the gods of the thermal camera tools will grant us like immediate access to the Wi-Fi thingy. Probably not. Let me check what IP it got. Has it been off for very long? Not really. Oh yeah, okay. It's got the same number, so that's... Oh, okay. More updates of the app. Let's do that. Fix some bugs. Yes, I'd like that. Will it connect first time? Well, I would bet no. So we're not going to do a poll about that. But who knows? Maybe the new app version fixes it. Let's go install. You always have to update your apps during the video, during the live stream, right? That's the best way to do it. Thermo tools. Yeah, let's go back here. Right, video, connect, LAN. This should be it. Connect. Failed to connect to the device. It can do RTSP, so it's not broadcasting. You still have to subscribe to that, but yeah, it can do RTSP. But the problem with that is that then the overlay is gone. So that's kind of useless. So I need to connect with the app, and for some reason that's always like, I don't know how hard, too hard. So let's go to Wi-Fi stuff and let's enable RTSP for fun. It doesn't really matter. It's just gonna keep not connecting because it's a piece of very expensive shit. I don't know. I have been looking at some new types. Intertan, they've been coming out with some new types I might want to test and add to the power sheet. So maybe in a little bit. You know, I've been busy with the boards and design. Oh, it connected. Wow, that's not bad. Oh, wait, the connection was interrupted. Oh no. Come on. Oh, damn it. It was there and now it's gone. Fonctionnaire, yeah, we have a freestanding house I designed 10 years ago that we're going to be selling because we're going to be moving to a new house, but yeah. Sure, no problem there, Matt Solomon. We keep producing those and making stock, so I'll turn RTSP on again. Maybe I should zoom out a bit. Whoa. Oh, we got a connection. Okay, so let's do this, and then I think I need this. Yes. So it's too big now. Okay, now I want it that big, but I need to adjust this. Okay. That should be good, and now I can make it a bit smaller. Okay, so let's see if it works. I need to take the macro thingy off. Yeah, there's one of my monitors. You can see me in the reflection. Here's another monitor. It's clearly edge lit, so there's like the backlight is like edge lit. There's my one of my switches, which has wait, how am I going? Oh, there, which has a 10 gigabit copper link in there. As you can see, because it's nice and warm. How warm is it? 54 degrees. Okay, I need to up, and we need to make the text size bigger. How do I do that again? There was a button for that. This button? Yes. Let's go this size. Okay, yeah, now we can see the font easily. So yeah, my SFPs are 54 degrees, but for a 10 gig copper SFP, there's actually 2 in there. That's fine. That's okay. And so yeah, let's see what more do we have. This monitor is, I guess, double edge lit? I don't know. And there's some LED strips on the wall. Oh, those are not, well, okay, they're not too hot in comparison with the... Oh, there's the power supply, which we worked on the last few videos. And we have some LED bars here in the ceiling, and yeah. There's a little camera there. You can find all the hot spots. So there's a power supply for the back wall. Oh, you can even see, oh, the ESP on the back wall is getting warm. Yeah, okay. So that works. So now we have this. So we just don't close it anymore for the whole stream. Because, well, you know... Oh, the drinks. Can we see the... Yeah, the drinks are nice and cold. How cold are the drinks? 15 degrees. Okay, and this one? I can also, like, hold it like that, and then you can see my... Oh, okay, not too much. Oh, this one's colder, 13.9. Yeah. But this camera is pretty good, because if I do this, there's my hand, and now I remove my hand, you can read my fingerprints. What's this? Where's this? Oh, this is where the can was. You can draw on the desk while nothing's actually happening. Yeah, okay. Anyway, this isn't the... With the real camera, no, that's going to be difficult because everything's mounted down. Because my camera, one of my cameras over there, and there's also my two charging stations which feed the cameras with permanent power, and all kinds of other stuff on my desk. And oh, we have the new power plug stuff, and yeah. Anyway, this isn't the thermal camera show. I did want to check if in the software I could enable the middle point view. Yes, okay. This measurement I was missing. So then when I point at something, it'll always show the temperature in the middle point there. It's actually, the liquid is like much warmer at the top than at the bottom, or the can. So if I do this, yeah. Now it's mixed. Funny. Okay. Anyway, yeah, like and subscribe for the thermal camera show. Basically, I ran out of room. So it's still here. I have one, and the cable is still there, but generally it's pretty hard to set up, and mostly the top-down view like this is plenty. Yeah, maybe in a future setup we'll do so again. Oh, that could be true also, the LED scientist. Right, so today we're going to do multiple tests, I think. I think we'll start with some load tests, and then after that we can also do some functionality tests if we want to. Okay, so this is the new Dig Uno version 4. It has various changes in there. One of the features it has is a much enhanced ESD and over voltage protection. So things like lightning strikes and stuff like that for the power and for the data lines will be much less of an issue because they're now more protected. There's a new DC-DC circuit on there. It's still 5 to 24 volt. It's just improved with a better IC and things like that. The level shifter design is mostly the same, except we now have a single switch for both channels instead of one for each channel. There's some filtering in there and a big capacitor. We now have an I2C port, so we have some extra ports. I realigned the pins so those fit a bit better. I'm thinking of including the temperature sensor by default again, because that's a nice feature to have. And well, they're made to work together with the new ESP32 version, which also has various enhancements. So it no longer has an LDO on there. It has its own buck converter, and then it has circuits to protect from ESD on the 5 volt and 3.3 volt, but also for protecting for over voltage. So hopefully we have less dying ESPs on there. There's now a default microphone on all of the boards. Yeah, it has 8 megabytes of flash and 2 megabytes of RAM. Yeah, and various other circuit and functionality upgrades. It no longer has diodes on the input, but it uses load switches, which makes it more efficient again. No data lines near the edge of the board. What? Yes, the problem is that requires a very, very different circuit, MedVet, for 48 volt support. And I did that on the Dig Next, but that's a pretty expensive circuit and also pretty big. and it would require a complete functionality change of how the board and how all the ports and stuff like that work. So no 48 support, no 48 volt support for the DIG Uno and DIG Quad. DIG Octa you can do with the Power 5 HV. And of course the DIG Next 2. So that will be a differentiating feature. It has DIG Next is like it has multiple differentiating features versus this guy. So yeah. Ah, okay. Well, that's probably on the DIY design, and they're now pretty separate. So yeah. Nice, Akun. So yeah, they can be mixed. You can use the new ESP on the old boards, or you can use an old ESP on the new boards. It's going to be a change because the pinout is also very different. But yeah, they are pin compatible in that sense. You just have to change the configuration then. Yeah. Yeah, the new smaller fuse, that is basically to get all the stuff on the board, because one of the big changes I did, there's now no components on the back anymore, and all components have moved to the front. But of course, the front has much less space available, so yeah, we went to the smaller fuse to make it fit, basically. And the DIG Quad is basically a lot of the same circuit, but differently designed. Also, no more components on the back. We have some very nice clear silk screen and things like that. So that's basically all done. So we have all the LED pins. We have all the other pins here. Oh, the circuit for Q1 and Q1R has changed. It's no longer a level shifter, but it's using proper load switches. And for the first time ever, we also have, don't know if I can show you here. Oh yeah, we have Q1R on the DIG Uno. So that's an improved feature, like having the I2C port over here, for instance. So it's more small iteration and changes. Basically, the board internally has been redesigned from the ground up. But yeah, I mean, it was already pretty feature rich. So yeah, that kind of stays that way. Yes, the physical dimensions is 100% the same. So the screw holes, the terminals, all kinds of that kind of stuff has not changed one bit. So all cases and everything like that will still fit. Especially if we're talking the antenna board version for the ESP32. So if we're talking this guy, yeah, this is the exact same form factor it's had for quite a while. The only one that changed is this guy. Because this is, as you know, an Ethernet option for the DIG Uno and DIG Quad. But, ta-da, it's now a single board. And this was quite a complicated board to figure out. Because we have this giant Ethernet socket here. And we also have this big ESP over here. But we also have this USB-C. And here you see more pins of the Ethernet socket. And all of this has to fit. And there's pins over here. All of this has to fit three-dimensionally, because you can't say, I'll put the ESP over here, because, well, the Ethernet socket and the pins are here. So, I mean, that doesn't fit. And then, like, over here, there's basically, yeah, this was quite the puzzle to figure out. But I did it, and this has been working great. It's now a 6-layer PCB, which is kind of insane. But it also has the upgraded features, so ESD protection and over voltage protection. It has now load switches instead of diodes. It has a onboard buck converter instead of an LDO. Onboard microphone. The Ethernet type has changed to where it would get the clock signal internally from the ESP32 before to have an external clock signal. So you can use a microphone and Ethernet and ESP now at the same time. Yeah, but this was... I mean, this doesn't look that dense, but you have to imagine in 3 dimensions, like, I can't put a via here because over here it's like in this component. Right? So you have to keep that into account when designing it. It becomes a lot more complex when you have components on both sides. But it's now a single board, and you can even use the... how do you call it? Let me let me demonstrate. You can even use the USB-C there together with where are we? Give me a cable there. Together with an Ethernet plug here. Yeah, you can even use that at the same time, and it fits perfectly. This is a new version, yes. A new version I'm working on. It'll still be a few months before it's available, but yeah. Yeah, so also height-wise, it gets a little bit larger or higher pins than the normal ESP32. So if you compare them, you can see that the pins are slightly longer. But compared to the old solution, yeah, it's a much more compact board height-wise. Because if it's on the Dig Uno like that, well, you can see, yeah, it's basically as compact as it can be, because this terminal is here and the components are underneath it. Yeah, and you can still reach the USB-C. It's a little bit, you know, if you have a thick plug it doesn't fit, but otherwise you can. Not that you need the USB-C, but yeah. Yes, the ESP will clear the screw terminals. Yes. Exactly. So no touching there, all good. Well, if you look at these kind of plugs, these aren't too bad. And one of the other things that changed is now the lip is on the top. So you still have plenty of space for the USB. Oh, it's not, you know, this terminal's kind of in the way, but you can make it work basically. If you really wanted to have USB on there. Do any of the Dig boards work with PoE? 90 watt. Yes, all of them do actually, Matt Solomon. I did a live stream about that. Where you can use external extractors that cost 4 times as much as the Dig Uno as a whole to extract the PoE power and then use it, you know, behind an Ethernet cable. But that kind of functionality will not be built in. So, are you talking about the AE Plus, Greg? Because I'm not sure what you mean with the fuses and LED channels. Because the data channels aren't linked to any power channel. So if you use LED 2, you can use power, whatever this, that doesn't matter. You can use any of them. So those are not linked together. But the AE Plus will probably be discontinued at some point. Because the microphone is now basically built into all the boards. We also have an external antenna variant, for instance. Yeah. Anyway, that is feature talk. Feature talk. Maybe I haven't actually measured that, Hakun. Let's measure that in real time. Let's see. I guess we should do it like this. How to best measure that? I'm trying to angle it so you can see. So let's have this stick out a little bit. Yeah, about 3 centimeters. It's squeezing it a bit, maybe. But close enough, right? Yeah. Well, the pins still stick out, but yeah. Yeah. Sure, no problem. That question, do you ever just sit and chill and in your mind always mine's always racing, yes. It's more an issue of time than what I want to do, right? Because I want to do a lot of things, and yeah, time is often the issue. Yes, TS Productions, that should be no problem. Yeah. Let's say July, Samir, because these prototypes will be sent to CE testing labs, including EMI and EMC testing and things like that, because it has a lot of new circuits on there. And Once that is done and verified, I can take them into production, and then we need to have a whole transition period, and I need to write like dozens of documents, dozens of web pages of documentation, and lots of stuff to do. It's fun designing the hardware, but then the hard work starts. Okay, so let's hook up this Dig Uno. And the Dig Uno load test is going to be fairly easy because it only has a few ports. For the Dig Quad, we'll have to build a little bit elaborate setup, but you know. So let's see, yeah, that's well connected. And then I have my load testers here. Let me pick one of them because we only need one. For the Dig Quad, however, we'll need like 4 load testers, but we'll figure it out. Let's see, you go here. All right, I need to open this terminal. Yeah, I can't really release these without documentation and videos and all the things that come with it. And that is a lot of work. That's at least as much work as designing and testing the boards and stuff like that. So, yeah, you know. Why do you not want to go in? I guess it's a Virgin terminal. No, I think I used this one before. There, okay. Yeah. And these terminals always take a little bit of work. There. So we're going to be testing it without the ESP on there because that's not what's interesting for this test. This is going to be purely a load test to see, well, if the board can handle the load I've rated it for, right? And then double. Any new LED strips in the works? No, not really. Currently not. I don't have anything to improve on the current ones. So tell us more what's behind the plans. Well, there's lots of stuff I'm working on. But yeah. So let's see. I think I can... No, I need to turn... Oh, okay. I need to turn this off. So I'm going to show you the AC meter, but it's going to be skewed because I'm using the bench power supply for this. For the other tests, we'll use a real power supply for the Dig Quad tests, and that should be more accurate. But let's see if we can... Oh, okay, it's off right now, so let's see if I turn it on. If this auto refreshes and works. That would be cool. In theory, it should. Can we refresh the web page? Maybe I have to turn it off and turn it on again? No. Let's check Home Assistant. Stream. Oh, okay. In the stream stuff, it's also not working yet. It probably needs to get on the Wi-Fi and... The Quinn Wear, your upcoming fashion brand. You do know I'm like this one guy who's doing this, right? I can't really do more stuff. Oh, there it is. Cool. So that's working. That's fun. Okay, nice. Okay, whatever. Okay. So now we can measure power. So this is the idle standby power of the big power supply and the bench power supply. Is there like a roadmap or do the function... yeah, I have like plans, but it can be variable how long plans take. Like last year was actually a pretty bad year because, well, I basically released no boards. And that was not the plan. Yeah, but we're going to go in strong this year and release a bunch of stuff. We're not going to test with 100 amps at 230 volts. Okay, we need to bring the load testers online. Let's see. I only need one there. Because then, in theory, the app will somewhat work. Now, one of the things I'm also working on an updated version of the Brainboard, and I want to make a more powerful version of the Brainboard, and I'm working on diff power, and there's all kinds of stuff going on, but it always takes much longer than you'd like it to, right? Okay, this needs to go here, and then I need to resize this. That's the downside of using Chinese tools. It's all not really meant for purpose. I don't know. Okay, and now I need to go into OBS and I need to say, okay, I want the A-torch thingy there. Okay, can we connect? Let's connect. Oh, we are connected. Okay, good. Okay, let's move the thermal camera up a little bit. Oh, it's almost like it fits. There. Okay. So now we have the AC side, but we also have the load tester side. So let's start easy with 1 amp. No, we need to enable a voltage. Let's say we do 12 volt. And I'll limit the load, the bench power supply. Still haven't gotten that interface online. To 20 amps, but let's give it power. And okay, we see that it's using a little bit of power. And here we see 12 volt. So that's good. And okay, so now in the load tester, let's say start with 1 amp. Oh, right, and I need to fix some CPU bottlenecking thing, because I can already hear my CPU fan spinning because 1 core is being overloaded. Still haven't automated that yet. This one, set affinity. You can have these cores. Okay. Yeah, it's overloading 1 core, but now it should switch to another core and then all is fine. You will probably fall asleep before 10 p.m. Well, that's 19 minutes from now. Okay, well, as expected, let's see what the board does. Where is the board? The board is, I'm touching the capacitor. The board is not heating up. Okay, right. Let's go to 5 amps. Go. Okay, it's ramping up. Yeah, we can also see it on the AC side, but the wattage you see there is before the big power supply, which isn't greatly efficient or whatever. So, yeah, take that with a grain of salt. Oh, we see something getting warm. Let's put on... Hey, it's Philip! Let's put on the macro lens and see what is getting warm. Yeah. So we have the board here. Okay. That is clearly the fuse. Nothing else on the board is getting warm because nothing else on the board is doing anything. So, you know, it kind of makes sense, but you never know. Okay, so with 5 amps, the fuse heats up. Big surprise there. Yeah, that's the fuse. Yeah. So, if I put this over here, maybe it'll stay in focus. No, okay. Well, we're talking about this white thing here. That is the fuse. No, it is. It's a fuse is a thermal device. So the closer you are to its limit, the warmer it will get. And then after a while, if you're at the limit or over the limit, it'll overheat basically, and that will kill it. No, we just started the first test, Philip. I did do a whole breakdown of like the new ESP boards and the new Dig Uno and Dig Quad and things like that, but I looked at the e-fuses, but they're kind of limiting in like voltage support and other stuff. If I use those, I wouldn't be able to do 48 volt, or I wouldn't be able to do 5 volt. They're quite expensive, and I mean Falcons and things like that, much more expensive controllers. The ESP also has limited amount of pins. I looked at implementing those, but there's some, issues with doing that. Yeah, no worry, Functionaire. So yeah, 5 amp really isn't that spectacular. So let's go to the max realistic load I'd recommend for the board, 9 amps, because we have a 10 amp fuse, right? So that means it'll start heating up. Because we're getting to like 90% of what the fuse is rated for, so it'll get a lot warmer. As much as I love seeing magic smoke, it's highly annoying when it happens to myself because then it's back to schematics. Yeah, yeah. Okay, let's check the back of the board. Well, you can clearly see where the power plane is, right? So this is the power plane before the fuse because it's connected to this terminal here. And then over here, we have a power plane that's connected to the exit connector, right? You can clearly see that on the board. But the power plane currently with 9 amps going through it is, well, over like in the warmest spot, it's like, I don't know, 41, 42 degrees. That's fine. These are normal thermal fuses. Sure, we can go to 10 amps, but a 10 amp fuse should generally not be run at 10 amps. And for normal scenarios with a Dig Uno, I also don't expect that. But we'll see. We'll see how far it goes and when it blows. Let me put on some safety glasses for that. But we can go up to 30 amps with this setup, so, you know. Well, no, that's a common misconception. At 10 amps, it will probably live indefinitely or die in, like, a week or two. And at 15 amps, it'll probably die in, like, an hour or two. And at 25 amps, it'll probably die in, like, 5 seconds. And at 40 amps, it'll probably die in, like, half a second. So that's kind of how fuses work. Neighborhood-wide power outage. Sorry, it wasn't me. It wasn't me. Okay, so now we're at 10 amps. We're seeing quite a bit of voltage drop because the tester is only showing 10.87 volts. Let's check with the multimeter to see if the board is actually dropping a lot of voltage or if it's the wiring. Right, so let's turn that on. Well, yeah, it'll pop at 1 or 2 amp above rating. It could just take days. And these are fast blow fuses. I ship all my products with fast blow. Let's see. Let's connect the multimeter also. So much software here running. Let's see if that works. DMM window. Where are you? Not sure why I'm not seeing my DMM, East DMM. Yeah, that's good. Oh, okay. Yeah, okay. I see why it's not working. There. Okay, that might be a bit confusing, huh? Let's move this over here. There. Okay, so we can measure the input voltage on the terminals, and we're seeing 11.5 volts. So we're getting half a volt of voltage drop from the bench power supply to the board already because of the cables. But if we have 11.5 volts going in, let's measure on one side of the fuse. And let's measure the other side of the fuse. Yeah, so this is the starting side of the fuse, because remember, the fuse also has resistance. That's why it's getting warm. So one side of the fuse we see 11.46, and the other side of the fuse we see 11.39. So already losing voltage there. And then from 11.39 to the output terminal, we see 11.34. So the amount of voltage being lost on the board, well, it's quite little, isn't it? How do I... Okay, if I put my negative probe on here... Okay, so another way you can measure this, you can put your negative probe on the input and then put your positive probe on the output, and it'll actually measure the difference between those two. And we see that we're losing 0.159 volts, or 159 microvolts, right? If I do it like behind the fuse, we see that the trace on the board is only losing like 55 to 60. So 0.06 volts is lost on voltage drop on the board while doing 10 amps. So if I didn't have like as much copper there, the voltage drop on the board would be much higher, like the voltage drop on the cable is, right? So I'd say that's, you know, losing 0.05 volts, so not even 0.1 volt on the board, while doing 10 amps. Because if we now lower, let's lower the power to 1 amp. Okay. And if we now measure between here and here, we see only 0.06. Oh, it's still going down because the copper is warm, and you know. So that means even with 10 amps, we don't even get 0.1 volt voltage drop. But since it was doing 10 amps for I don't know how long, let's go to 15 amps. Okay. So let's see how much voltage drop we're getting over the board now. Okay, now we're getting 0.3 volt voltage drop, but... Oh, I'm already starting to smell it. Let me check. Yeah, oh, you see that? It's way over temperature because we're over 10 amp and we have a 10 amp fuse. So the voltage drop we're seeing, oh, it's now 195 degrees, 197. But 15 amp isn't a lot above the temperature or the current the fuse normally runs at. So it'll do this for a little while. But I can smell it. And we might get smoke. I don't know. No, it doesn't look that interesting yet. See, the temperature keeps climbing, and at some point it'll go pop. Was that smoke? No, that was my hand. We're still climbing. How warm is the middle? 140. So this is basically the worst way to pop a fuse, right? By slowly overcurrenting it. Yeah, we could get a burn mark on the disc. Let's see what our voltage drop on the board is now. Oh, we're already up to 0.4 volts. See the resistance increasing? Oh, yeah, okay. Yeah, this fuse is going to blow real soon. Oh, it blew. Yeah, it's dead. Yeah, okay. Well, nothing spectacular. But that's the whole idea. So even with 15 amps, you can very quickly blow this fuse. Now, one of the features the Uno and the Quad don't have, which the Octa and the Next do have, is broken fuse indicators. There's nothing to indicate now that this fuse is broken. Actually, this still works because this runs through its own auto reset fuses. So the board will still stay online, it just won't give any power anymore. But there was no way to include this in the board, and all extra features also raise the price, right? So that stays an Octa and Dig Next feature. Yeah. So let's turn this off now, and let's get a plier. Well, okay, let's get a smaller tool to remove this fuse. If it still wants to go. Board is warm. Okay, there we go. Well, there's nothing really to see. It just died very gracefully. Okay. I'm gonna steal a fuse from some. Well, wait. Maybe we should test. Let's see if I have larger fuses, because it is clearly written on here that I recommend a 10 amp fuse, but you can use a 15 amp fuse if you want. So let's get a larger size fuse, and let's over test the board. I should have gotten the fuses. Where are SMD fuses? I have a bucket. I have a bucket named SMD fuses. I think that's the one we need. I'm not sure I have a 30 amp. This is the fuse blower boards, if people remember. That's what we initially used to test these fuses. And then I decided to design with them. 50 amp? Wait. Is this a 50 amp version? No. No, I think it's rated up to 50 amp. Yeah, that's not a 50 amp. Okay, never mind. Let's see. 6.3. Holder 7. 8. 5. 10. I need to see if I have larger fuses, actually. 5, 7, 10. I have them from various brands, because I tested all kinds of brands. 10 amp, 7 amp, 6.3 amp. Yeah, I generally use smaller ones. Okay, let me check this guy. That is the bench power supply and the large power supply feeding that one function here. Yeah, but in this case, the ESP will stay online because it has its own fuses. But yeah, okay. This is holders. Let's see, 5 amp, 4 amp, 2 amp, 10 amp, 3 amp. I don't actually know if I have larger than 10 amp. That's a good question. Maybe I never ordered those because I basically never use above 10 amp. And then we have to get creative. I don't know about that. Hey there, John. Let me check these bags. 500 milliamp. 10 amp. 6.3. 7. 8. 12. 15. 20. Okay. I do have bigger ones. Good. So let's say somebody did stupid. And let's verify this is a 20 amp. Well, I was considering it. But these should be 20 amp fuses. Which is not recommended, but you know. Doesn't mean people won't do it. Let me get my enhancements. Yes, this definitely says 20 amps. Okay, let's try that. Well, actually, if you would solder two together, in theory, if resistance would divide, but in practice, that doesn't really work. Yes, okay. So let's get this out of the way. Okay, let's go 20 amp fuse. They are a bit hard to get in sometimes, so I just use a tool. There. Oh no, the logo isn't on top. Let's rotate it. There. Always press them in a bit. There. Okay, good. Okay. Here we go again. I'll try and see if I can lock focus on it. Where is it? Oh, set. Memory card full. I don't care. What do you mean? Okay. I'll wear my glasses again. So now we have a larger fuse in there than I'd recommend. And it could be that my heat sinking of the socket won't be enough. But I don't know. We'll figure it out. Let's power it on. The load tester is again seeing 12 volt. So let's... Yeah. Let's start with 15 amps. Okay, that's working. We're seeing a bit more voltage drop, but that's expected, you know, because of the cables and things like that. So let's measure it. Okay, we're seeing 0.125 voltage drop, including the fuse. And without the fuse, we're seeing 0.47. So the board itself is dropping 0.05 volts. So yeah, that's not a lot at all. So the board has no issues whatsoever transferring 15 amps. I guess we can just go to 20 amps. Okay, we'll go to 18 amps, right? Because that's comfortably below the 20 amp fuse limit. Do we have a fire extinguisher? I have my my fire stop, but it's from... Where's the date? Yeah, it might not be valid anymore. No, date of production. Okay. But then how long can I keep it? It's almost 10 years old. No, it is almost 10 years old. Oh. How long can you keep it? I don't know. Does it say? Oh, uh-oh. 3 years after production, it should be replaced. We never knew. We did. La. Maybe we exceeded that slightly. Okay, well, this is getting pretty warm. The warmest spot is about 133 degrees now. But there's a lot of current running through there, right? This is above design specifications. You know, the fuse holders are officially made for that, so that's not a problem. But let's see how the board is handling that. From start to finish, we have 0.17 voltage drop. But if we don't take the fuse into account, it's only 0.06. So, maybe it wasn't in fully. I'm not sure why I can move the fuse. That shouldn't work like that. Okay. How much voltage drop are we getting over the fuse? 0.06. Yeah, okay. Or our voltage dropped quite a bit. But I think even the cables are probably heating up now. Yeah, the cable is like 40 degrees. And this one... Yeah, this is 16 gauge cable. That's also why I recommend a 10 amp fuse and not a 15 amp fuse. It's not like the board can't handle it, because we're doing almost 20 amps now. And let's see the back of the board. Yeah, this is now becoming quite hot. But that area is hot because of the fuse being hot, right? Not so much the board not being able to handle it. Because over here, we can see all the current running and then it's fine. But even the cables, with this kind of current, the cables are 60 degrees. I almost couldn't hold them. So this isn't so much a board limit, but a limit for the terminals, for the fuse holder, and everything is having high resistance, so generating heat, so things will just heat up. No, the voltage doesn't matter, only the amps. Yeah, the board is powered separate from this fuse, so it's not affected. Although this PTC is pretty close. So this component here, which I'm pointing at, that is a thermal fuse. And that is pretty close, but I imagine it would still work fine. So how many watts are we drawing? Okay, we're not drawing a lot of watts. So let's set the power supply to 30 amps. There. And let's see if we can blow this fuse. Let's try and draw 30 amps. Well, I'll keep my thermal camera on. I don't know what will happen because I've never tested this. Okay, we're going to 30 amps. It could be that it gets too hot. Oh, it's already dead. I can smell it. I think there was a little puff of smoke. Not 100% sure, but yeah, it's dead. It's dead. The board is still online, and this goes through the whole DC circuit because this is the 5-volt LED. You saw the flash. Oh, I missed it. Cool. Yeah. Okay. So that's dead. No, more watts generally doesn't count. It's the amps. So if we test with 5 volt or 12 volt or even 24 volt, it shouldn't matter too much in regards to how much heat is generated, because amps versus resistance generates heat. Yeah, okay. So we killed another fuse. I don't have a bigger fuse than 20 amps. But I think we can conclude that although things get hot, the heat is from the cable connection and the fuse connection, and the board itself. Oh, nice. Visible fuse blow. Okay, I'll look it up later. Or you can, on YouTube, I think you can clip it. Can someone try that? Then I can look at it later. Anyway, yeah. I'm going to say that this board, which I recommend for 10 amps, and it's okay to use a 15 amp fuse, so you're running like 12 or 13 amps. That is going to be perfectly fine. Yeah, and if someone decides to run 20 amps through it, I mean, you can't get the cables in the board that are big enough for 20 amps. It's not meant for that. No, you can also do YouTube clips. So, yeah. Okay, I think that limits our Dig Uno testing for now. No, we're not gonna put some. Even if we put double the rated recommended fuse in there, it still blows the fuse and nothing melted or did weird stuff, right? So, I'm gonna consider that A-okay. Because I do like rating things for like almost double the current, and that's basically what we just did. So oh, I had to bend this one in, I believe. Yeah, okay. Cool, okay, let's keep this one apart because we cooked it. And let's move over to its bigger brother, the Dig Quad version 4. And we're not going to use the bench power supply for that, because that's limited to 30 amps, and where we're going, we need much more than 30 amps. Okay, so let's disconnect this, get it off the disk. Okay, so this is an output wire. This will also be an output wire. Oh, Philip did it, I think. So we're going to use these on the 10 amp ones. Or the separate terminal ones. And we can later make it a bigger fuse. No, the DIY version, we did an update for that fairly recently still. And there's not too much I can update on that in regards to features and such, because it's all in custom circuits and like components and things like that. But you can use the new ESP32 with the DIY version and get like the microphone and the new Ethernet board and things like that. So that isn't a problem. Oh, I need to open these. It was honestly the best way to make it fit. Do you have to tell people not to use more than the recommended fuse? I mean, it's not recommended for nothing. It's always nice getting these as large as it takes wires in there. There. Because these are 16 gauge wires, and those are also not really rated for like 20 amps, but we just did it anyway. But that's why they were getting so hot. Okay, I have two load testers on my desk. Those will each have to 10 amps. So let's see if I have some 10 amp fuses here. 20, 12, 15. No, I need some 10 amps. Let me put the 20 amps back. No. This is a future Tesla. It'll be a while before these are released. So I wouldn't hold your purchases if you need a board. Let's see. Do I have some 10 amps here? 8, 7, 6, 10. Yes. Now, what I've seen a lot of people do, which I don't really recommend, but we'll do it for testing also, is take the 5 amp fuses out and put a 10 amp fuse in each of the holders, because they read, oh, you can have up to a 10 amp fuse, and then they think like, oh, so I want the biggest fuse in everything. I don't really recommend that, but we're going to do it today to test it, because the board is rated for 30 amps, but we're going to try and test it up to 50 amps with all 10 amp fuses. Or I guess we will test it to like 40, 45 amps for normal conditions. Oh, I want the stupid logo to be on top. It doesn't really matter. And I still want it. Oh, I still think I have some reversed. Oh no. There. There's a few angled components and things like that on there, yeah. Because over here I also had to squeeze some stuff in, and there's all kinds of resistors and things, and yeah. That's how it goes. It's like when KiCad starts beeping at you like all the time, like this isn't right, this is too close together, this is a problem, and then you tell shut up, go away. And then, you know, it still works. Okay. We now have 2 lines connected to the dedicated fuse outputs. We still have another dedicated fuse output left, and then the shared fuse outputs. But we're going to need more load testers. This is called an SMD fuse, or it's also like 1808. It has various names. But I have some pages for the Dig Next, for instance, or the AN Penta Mini, the AN Penta Plus, or the AN Penta Deca, where you can buy them and which fuses these are, things like that. So we're getting some familiar things on the desk. Here we have some of the older load testers, which we're going to use today to generate more load. And we can do that by basically splitting them over these 2 terminals, in theory. Oh, I need to join these together slightly. Let me try and adjust that. Oh, not too much. There. Yeah, perfect fit. Nice. So you can make on a Dig Quad and a Dig Octa, you can bridge 2 terminals. In this case, that's 1 fuse, but on a Dig Octa, you could actually use 2 fuses for increased load. Yeah. So if you want to use a large diameter cable, so this is 12 gauge, that doesn't fit in the terminals of the Dig Quad, but you still need to run it because you're running 5 volt and you need to go longer distances and things like that. You can basically use a fork terminal and bridge it over those 2 connections, which is still connected to a single fuse in this case. Yeah. Oh, I might actually have to adjust something here. Yeah, I need to adjust this guy. And then I have 4 here, so this guy goes over here, I guess. I don't know. Yeah, so even though these terminals are somewhat limited in wire ferrule they'll take, using this method you can still get 12 gauge or even 10 gauge onto your Dig Quad. And not so much for increased capacity, because the fuse is still limited to 10 amp, but for increased wire diameter if you're running 5 volt. Do I have another one? Yeah, like this. This should also fit well. Oh, this one's already quite mangled. Let's see if we can still get that in there. Yeah, okay, yeah, fit. Now screw that in tight. That should straighten it out again. Yeah, that should be going nowhere. And then this one can go here, in theory. Yes. Let's make sure those are nice and tight. Okay. So we now have 4 connections, which means we can go up to 40 amp with 4 times a 10 amp fuse. Let's see if I have one more which has the proper connections installed. Not 100% sure. Oh yeah, I do. This one should also work. Oh. Okay, I need to have different wiring. I don't think I can get these blue connectors to fit. Let me give it a try. No, power is off, so the switch itself is also off. Oh, I should have done this one first. Yeah, so this is, I think, 12 or no, this is 14 gauge. 14 gauge is just, you can get it in the terminals if you're lucky, but generally it's just too big. What I can try and do is get one of the forks in and see if we can tighten it down. I know what I need to do. I need to take this guy and just snip it off. Actually, I think my edge cutters would do that. Let's try it. Yep, no problem. Now, I'm not recommending you run like this. It depends on what you need the cable diameter for. If you need the cable diameter for the length, this is okay. If you need the cable diameter for the current, this is not okay. So let me make that very clear. Okay. Oh, I need to split this. So let me split it properly. Okay, there. You can also put the 2 sides of the fork together. Don't know what that means. Look at this poor little board. It has so much cable going out of it. This is fine, right? This looks great. If you want to run this much current, buy a dig off, please. Okay, but now we need to have the feeding wires. No, I didn't need these, damn it. Oh, I put them nicely away and now they're all mangled. Okay, hold on. The OSHA violations, yes, yes. All the violations. Okay, I have my 5-volt feeding wires here. Okay, we can put it further back, good. Those come from a UHP 500-5, so it's 5 volt. And I use my terminal blocks here to store them on my desk so they don't short. And these are 2 10-gauge wires, so that we will have plenty of input capability, because the UHP 500-5 can do a sustained 80 amps. But we only have 50 amp of fuses, so I mean, in theory we're not going to need that, but we'll see. We'll see how it goes. How does it work with the negative having 2/3 of the cable than the positive? I'm not sure what you mean there, Gareth. All the cables have the same connection right now. Ah, okay, yeah. There's more connections here, yeah. Because when I designed the board initially, I didn't want it to be wider than this, so you know. Okay. Hold on. Yeah, there. Okay, so. Yeah. I expect this to get warm with 50 amps. But remember, the official limit is 30 amps, so. Let's get some more power supplies for the testers. How am I going to do this? I'm just going to pull something else out. Oh, there. Let's see here. Let me put this to the side. We still have a thermal connection. That's nice. You can't connect, but once you're connected, it stays connected indefinitely. Okay, we need one more. Let's turn that on. Let's turn those on. Back to the old days. Oh, and we need to turn this one on. Okay, so now we have 5 testers connected with 5 cables over 5 fuses. So in theory, we can do up to 50 amp sustained, and our power supply can deliver 80 amps. So we should be good there. I need to turn this off. And then I need to turn this one on. Let's see, positive, all negative, negative. Yeah. Okay. Okay, turns on. We have ignition. We have green is 5 volt, yellow is 3.3 volt, and the Dig Uno didn't have, or sorry, orange, because that takes 3.3 volt from the ESP32, but the Dig Quad is already a step up, so it has a separate 3.3 volt circuit of its own. It doesn't take it from the ESP32. Well, nothing is getting warm. Where is the fuses? The fuses are... Here are the fuses. Yeah, no, well. Anyway, the DC-DC circuit is active, but, you know, nothing is connected. Yeah, I also have 3 times 25. Okay, so all the testers are online. I can do one using the software, the other, so we also have a voltage display. The other I have to do through the panel, that's okay. Is our power meter back? Yes, our power meter is back. I'm reading about 3.4 watts. That's reading 4.5 watts. That's, you know, close enough. It's not great at low power usage. But let's set this tester. No. There. To 9 amps. Start. Okay, yeah. We're doing about 9 amps with one tester now. Let's set the other tester here to 9 amps also. Or we can take a look at the fuses. Okay, we have one fuse that is heating up. It's a 10 amp fuse. It's set to 9 amps, so that's fine. Let's do the other one too. Yeah, okay, go. You can see the wattage meter increasing. And now we have 2 fuses doing 9 amps. Yeah, I think, yeah. Oh, we can already see a bit of heat on the one of the positive cables. Why only one? That is odd. What's going on here? This one's 30, this one's... Oh, okay, yeah. So, power will actually take the path of least resistance. And if you take a look, our load is both... wait, let me focus it real quick. Set. Okay, our load is both located on this side, right? So, here is our load. That also means that the cable that is closest connected to that, even if the cables are equal length, on the PCB, it's not equal length. So if the power has to come from this cable to over here, it's further away. That's also kind of what inspired this layout for power distribution. You'll see that if we, for instance, activate this channel, it'll probably start drawing it from this cable instead of this cable. That's a good test. Let's do that. Which tester is this? The first one. Okay, let's go to 9 amps. 9 amps. Go. So now we'll see this fuse heat up. And those pins aren't warm. That's reflection because it's metallic, right? So now let's see over here. Is one cable... Did I connect the wrong set of cables? It's also possible, of course. No? That's all connected. Yeah, it's all good. Well, we can turn the other testers off. Off. And then we need to turn the second one on. That is, I guess the second one, huh? 9 amps, go. Maybe there's an issue with my cables. That's also possible. Because I would have expected the other cable now to start heating up. Yeah? It could be a soldering issue. I mean, let's look at the back. So I would have expected the other cable to heat up now. This all looks fine. That is a bit odd. Let's look at the negative cable. The negative side, we see the same thing. So that is a pair. The inner ones are... No, that's not a... Is that a pair? No. Which one do we see here? The outer one is connected with the outer one here, but Ooh. So this is the inner one, and this is the outer one, but they're not connected together. So inner one, this one, and outer one here, are they connected together? No, this is connected to this guy, which is the outers are connected and the inners are connected. That's odd. Now, in the end, it's all connected together on the power supply. So, I mean, maybe there it's just slightly shorter. Let's add more load. It's always the good thing to do, right? Add more load. So now we have 3 fuses of load. It's about 44, 45. And this one's 35, okay. Same thing here. Huh. Okay, let's add all the loads. Let's see what happens. I added the other 2 loads. So now we're at 5 times 9 amps. Yeah, that's not what's supposed to happen. This cable is still about 40 degrees. This one is about 65 degrees. So you can imagine which one is carrying the current. How's it going over here? Oh, over here we see the same thing. One is much warmer than the other, but they're connected to the same block. Maybe I need to try and retighten them, because I haven't tightened them in a year or so. I mean, it's doing it, but we're getting a lot of voltage drop because we're now at 4 volt, because basically it looks like one cable is carrying all the current, while the other is doing, well, it's almost half the temperature. It is a bit shorter, but let's turn off the power real quick. So, beep, 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 beep. Let me retighten the terminals on the power supply. Yeah, they're not really loose either. Okay, let me retighten these terminals. I'll switch them around on both sides. And these weren't loose either. But if I switch them around, we can see if it was the cable or the terminal. Oh. Now I don't remember which one was which. I think this one needs to now go to this one, and this one needs to go to this one. Yeah. Okay. Let's turn the power on again. These testers will auto start, the other 2 won't. So let me do that. Come on. Yeah, okay, now all the testers are on again. Let's see what's happening. Okay, so the issue moved. This one seems 44 degrees now. That's not as bad as it was. But this one's already 66 degrees. So it's not the terminal. Somehow it's the cable. Right? Because the problem moved from terminal to terminal. So it's somehow related to the cables. Yeah, because my copper planes here are all fine. No problems. They're a bit warm at the fuses, but that's to be expected. Okay. Yeah, so on the power supply itself, this is the negative side. No, the positive side. We see that one is 60 degrees and the other is 51 and 53. That seems much more evenly connected. 48, 53, okay? And on the negative side, this one's 70, and this one's like 58-ish. 62, yeah, okay. 53, 56, okay? So let's check over here. Here we can clearly see that this one's like 74 degrees, 75, while this one's like 44. And over here, yeah, same thing. I mean, if we look at the cables on the desk, like that. Yeah, so we're getting a RTX 5090 problem. For some reason, we're getting an uneven distribution. Hit it with the crimping tool again. Yeah, probably, it could be. But I've used these cables for a while. So maybe they oxidized, I don't know. Yeah, they're the same cable, they're both 10 gauge. We can test voltages, that's a good one. Multimeter is still active, good. So let's see here. What voltage are we getting on the inner pair? Yeah. 4.68. And on the outer pair, 4.68. Well, I can't really test the cable individually because once it hits the terminal and the board, it's all linked together. So, you can't. Yeah, maybe I can test it if I have one lead on the power supply. Let's see. 192. 177, 177, 190. Yeah, there is a bit higher resistance on the cable that's getting warmer, right? So we have one pair that has a resistance of 173 microvolts and one pair that has a resistance of 184 or 85 microvolts. Oh. 89, yeah, and that is also the one that's getting warmer. No, other way around. The one that has less resistance is getting warmer because it's getting more current, which makes sense. Interesting. But it has less resistance, so it's taking more current. So, well, it had less resistance. Now it maybe has more, but ideally, but that's not feasible, Josh. Yeah. But okay, let's test some more stuff. We're still hitting the board with 5 times 9 amps. Oh, is this still on? Yeah. Okay. So let's see how much voltage drop we're getting from this guy to over here. 126 and to over here. 134. 146, 138. Okay, yeah, so we're losing about 0.14 volts, but that is with the fuse included. If we test without the fuse, over here, we're seeing 0.027, so that's very low, 0.027. Let's test over here. Oh, this one's higher. A little bit maybe. No, okay, I just had to press harder. Okay. And from here, no, wait, let's try that the other way around. It doesn't really matter. Yeah, 43 drop. Okay. It's heating up more because of the resistance difference. But I don't have the tools to measure the resistance without a load on there. Because then the resistance difference is so low that even my expensive bench power supply or bench multimeter can't do that. Yeah, interesting. So maybe these cables are just slightly uneven, which is giving us an uneven load distribution. Now we're running about 50 amps through the boards, and I recommend 30 amps, so, you know. Yeah, exactly, Josh. Okay, so the fuses are getting near 100 degrees. But that's fine, we're running them near the limit, so that is to be expected. Let's check the board itself, though. So we have the incoming power wire, that's adding a lot of heat to the board. But it's still, the board, yeah, there's some hot spots here. But that's exactly where the fuse holders are, right? The fuse holders bridge here and here. But if we look over here, it's around 70, 60, 70 degrees. That's still not critical for FR4, right? For the material this is. It can go like easily 150 degrees without sustained without becoming a problem. And then if we look after the fuses, we can clearly see where it's divided to the separate terminals, right? These have two shared terminals, and these have their individual terminals, and those are much cooler, each well below 70 degrees or 60 degrees even. So yeah, that's okay. Let me change the setting. Okay. Yeah, now we only see the hot spots, and that's clearly where the fuses are. Yeah. You can see the on the power meter, the right one is a power factor. You can see that this is an expensive power supply because it has an active PFC. So it has a PFC factor of 0.96, so almost 1. You've caused the discussion. How dare you? No, that's okay. That's fine. We're here to hang out too. So let's go back to more of the limit of the board, because we're currently with 4 times 9 or 5 times 9. Let's say we have 30 amps divided by 5. That's 6 amps per tester. Okay, let's go do that. Okay, now we're at 5 times 6. Yeah, I mean, the fuses were running near their maximum, so they get really hot when they do that. So they generate a lot of heat that also goes into the board. We can also see a lot less voltage drop now. Yeah, no, it was running at 45 the whole time, Foxionaire. But it's now running at what it's rated for, 30 amps. And now we can see that the voltage drop, 50 amps, yeah, basically the way we've mostly described it is 30 amp continuous with 50 amp peaks. Well, we saw that it handles about 50 amp continuous also. So, I mean, that's no problem. Let's take a look from the terminal to this terminal. We're now seeing 0.079, so not even 0.1 volt drop from the input to the output. So through the board, through the fuse, etc. These are a little bit higher. Okay. And if we take the fuse out of the equation, so from the output of the fuse to the terminal, yeah, that's really minimal. Not a problem at all. So even when running this with 5 volt, which we are doing, this won't create any issues or voltage drop because of the board. So Hakun, in my article, the fuses I have linked there, those I've all personally ordered and tested. The board comes delivered with fuses from Little Fuse, so that's a known party which has data sheets, etc., etc. I will also start offering replacement fuse packs, which will also be from Little Fuse, so from a known good brand with data sheets and guarantees and blah blah blah. But all the AliExpress vendors that I have listed in my articles, I've personally tested and blown, and I've blown, well, hundreds of fuses, I would say. Yeah, exactly, Philip. Yeah, so those, in my opinion, are fine. Yeah, but the fuses you get with the board are brand fuses. Yeah, so now we're at 30 amps still. Fuses have calmed down nicely. Still one terminal that's warmer than the other. Not sure what to do about that right now. Well, I don't like recommending things that I haven't tested, so I tend to test a lot. Yeah, the only way to test them is by blowing a handful and then averaging the data and then seeing how well they did, basically. With a DuPont cable, no, I don't want to test with a DuPont cable, but I will test with some shorts, that's fine. Thanks, Foxionaire, that's appreciated. So let's see if we have some cable here. I actually don't think so, because I used it for other stuff. I think maybe in here. Oh. No. Where's my box of wires? Short wire. That looks like the box I'm looking for. It's always good to have a box with short wire. This can handle a bit of current. It has wire ferrules and everything. Okay, so I'm deeming this test... Oh, we didn't really look much at the negative side. But this is really... The negative side kind of more reflects what the board can handle. Because all the heat we see over here is clearly being generated by the fuses and not so much the board. Because the negative side, well, we're still running 30 amps all this time. And the board is like 34, 35 degrees, doesn't really care. Yeah, the terminals aren't warm or hot or anything. You can look at the back. You can see the negative side here. There's almost no heat. That means there's plenty of copper there to transfer the current. And only because of the fuses here do we see all this heat here consolidated. And that's not so much the copper, but there is enough copper to basically dissipate the heat. Right? Because if there wasn't enough, things would overheat. And the middle, where the electronics are, stays nice and cool. So that design still works great. Okay. Let's turn this off. Should we blow some fuses? I think we should. I don't know. Let's disconnect this wire. And that is connected together with this fuse. Now the Dig Uno and the Dig... no, this is 4 layers still. The Dig Uno and the Dig Quad have always had... well, the Dig Octa and the Dig Next 2. But have always had special circuitry on there to try and pop a fuse as quickly as possible. Basically, there's diodes on there in reverse. And once it makes a connection, the diode will basically help draw as much current as possible and try and pop the fuse so that whatever short there was is very short-lived. So it's not just the current going through the wire, but it's also a board feature basically to pop fuses. Deliberately pop fuses quicker. Okay, so oh no, we've accidentally wired a loop from here to there. So let's get this fuse in the view. Oh, no, this is black. This is all, I did it correct. I did it incorrect. So everything is still connected, but let's turn on the power, see what happens. Oh wait, the load testers automatically start. Okay, well, yeah, it already blew. Because, you know, the power supply is capable of delivering 80 amps, and even though it's a dead short, and, you know, people say like, oh, you don't need fuses. Your power supply will protect you. What? Maybe. But maybe it just didn't. Because, you know, yeah. Oh, did you guys see a flash again? I didn't see it. This is another dead boy. Yeah, but then what do you fuse at the power supply? Also 10 amps? Then why do I have an 80 amp power supply? Should we also put a 20 amp fuse in there? See what happens. Is this the 20 amp fuse bag? No, this is the 10 amp fuse bag. Where's the 20 amp fuses? They're holding the desk now. Wait, 50 15 amps, 20 amps. Let's see if people are stupid enough to put a 20 amp fuse in there. You know they'll do it. We both know they'll do it. They'll be on AliExpress and like be like, oh, we can get 40 amp fuses. That means my fuse will never pop. Now I don't have to replace my fuses the whole time. And that's like the worst logic. But they will think like that. So, okay, let's say somebody put a 20 amp fuse in here. Okay, I'll try and keep the temperature camera. I have a fixed focus difference, so I can't really, you know. Okay, board is in focus. Let's go. Power on. Oh, there it goes. It's already gone. I think. Yeah, it's gone. It's already gone. I don't know what to say. Okay. This is not very exciting. The music's making it very epic, okay? Yeah, but this is also what we said, like, if you deliver enough current, the fuse will go like that. But if you only deliver a little bit amount of current, it'll take a lot longer, like we saw before. It's actually an interesting test. I haven't tried yet. We can try real time here. I have these long cables, which I use for data testing, right? So let me check which one. This has a label, is 10 meters of 18 gauge. And this is 15 meters or about slightly longer of 16 gauge. Let's link those together. Wait. Yeah, let's Wago those together. And then put a short through it. And see what happens. So let's take the red wire here, and we'll leave it nicely coiled up, because, you know, coils. I'm not sure I can get this one in the board. I think so. Yep. Okay. Oh no, that's white. I want red. Ah, no. Okay. Sometimes these terminals are annoying. There. Okay, and then we wagoed it together, and we take the red one on this side. Okay, so now what we basically did, we added, well, you can't really see, hold on. There. We added a whole bunch of resistance, right? Where's the baggie with fuses? Oh, I put it back. Now let me start with a 10 amp fuse. Because that's what the board is delivered with, and that is partly with a reason. Because the higher your fused value, the lower the chances it'll catch it. But now we added we added like 25 meters of resistance. So I still think the 10 amp fuse will pop before the wire does. But I don't know. Let's see. Let's see if this makes a difference. Let me try and focus it correctly. There. It's not in front of it. Will the wire melt or will the fuse melt first? Let's see. Go. Oh, it's still not popped. We're drawing 75 watts. Still drawing 75 watts. So this is the effect of resistance and why you shouldn't use a 10 amp fuse if you're only going to draw 5 amps. The wire is still not really warm, so that's good. If we look at the wire here, that's not really a problem. Wire here, you know, it's warming up, but it's not yet a problem. Oh wait. Yeah, so basically we're having a sustained fuse, and even my special circuit can't help enough with that. But, you know, the wire, yeah, it's starting to get a little warm. See that? It's starting to heat up. Yeah, probably if a 20 amp it'll go forever. But actually a 10 amp, and this is 18 gauge, I believe, I don't think either will win. I think it'll just keep shorting forever, because there's also only so much this can heat up. And in a normal situation, your wire won't be coiled up like that. And having coiled up wires, like especially like this point here, well, you can probably see it. That's where it's going to heat up because all the wires are bunched together, so it heats itself. And like also over here, but this is 16 gauge. Yeah, it starts heating itself. So, but if it's laid out flat over a very long distance, it'll be able to dissipate that heat a lot better. So yeah, I don't think this is going to pop. Yeah. And that's also the reason why the board is delivered with twice 10 amp on the shared terminals and then 3 times 5 amp. Because you can only get about 16 gauge in here. If we'd be able to get 12 gauge or 10 gauge in there, even for the same distance, it would probably pop the fuse because then the resistance is much lower. Exactly. We're still drawing 70 watts. It has to go somewhere. Okay, well, we can wait indefinitely for that. Let's take it out. So that was a 10 amp. Let's replace it with a 5 amp. There. And let's see what that does. And a 5 amp fuse with an 18 gauge cable, that is more appropriate. So, yeah. Okay, let's go. Did it already die? Okay, maybe that was a dud. Maybe the capacitor still had enough juice to kill the fuse. I don't know. Is that a thing? No, that's not a thing. There. Okay. Let's try that again. Everybody pay attention. Oh, there it goes. Yeah, I just killed it instantly. Yeah, okay, it's just dead already. Okay. So, I mean, that clearly demonstrates the difference between a 5 amp and a 10 amp fuse, and why you shouldn't just put 10 amp fuses in everything, which I see a lot of people do, sadly. Because if you don't have the copper connected to it to sustain that, well, you could create a permanent short. Now, the board won't catch fire because the board's rated to handle all of that. That's no problem. But at some point, your wire could catch fire potentially. If you fuse it, if you have like a 22 gauge and you fuse it at 10 amps, well, the wire is probably going to go before the fuse does, right? So that's why having the right value fuse is very important. Don't just put 10 amp in everything. This is also why I think delivering your controller with a single 20 amp fuse is the wrong thing to do. And I'm not going to name any names, but there's other controllers out there which kind of looked at my boards and were like, oh, this guy has fuses. We need fuses too. And put a 20 amp fuse on there, but then they can't really accept a larger cable diameter than mine can. So, yeah, you do the math. The operational temperature, it's FR4, so sustained, I think they recommend not exceeding like 85 or 100 something degrees. So around the fuse holders, if you're going max load continuous the whole time, which doesn't make sense for addressable LEDs, but okay. Yeah, you'll reach up to 60, 70 degrees. I could put more copper in there, but as we saw with the 30 amp scenario, which was 5 times 6 amp, the temperature were much lower and very much in control. And the heat was coming from the fuse holders and not the copper itself, because there's plenty of copper in there. No, it's okay, Greg. It's okay. Heat sinks. Heat sinks for what? Because if you're talking about heat sinks for the fuses are a thermal device, which is the whole function is that it generates heat the nearer to its limit. So putting a heatsink on a fuse would alter its characteristics. So if you like actively cool a 5 amp fuse, it wouldn't be a 5 amp fuse anymore. It would be a 7 or 8 amp fuse, because now it needs to generate more thermal energy to pop, basically. Heat sinks for the board in general, I don't see a need for that. Everything is properly cooled. So I don't know why we would want a heatsink. Oh, and why I moved away from the blade fuses. These are actually more expensive for me, because the holders are pretty expensive. But on the other hand, it's not through-hole and SMT. And mostly the reason was space. So if you look at the Dig Uno, especially, I couldn't cram all of this on the board, and I'd rather not alter the form factor because of cases and stuff. I couldn't cram all of this on the board if I didn't use the smaller fuse holder, because this is really tightly packed. Because even there is a tiny IC. Can I do this? Wait, how does that work? No. Yeah, I can. So even oh wait, oh, camera doesn't know how to focus that. Okay. Yeah, okay. So even there's a tiny IC, and there's lots of stuff crammed in there. All kinds of passives there, and load switches, and level shifters, and ESD protection, and over voltage protection, and yeah, there's lots of stuff going on basically on that board. So for the Dig Uno, I literally couldn't get it to fit. The Dig Uno is a 4-layer. This is also a 4-layer still. The Dig Octa brainboard moved to a 6-layer. Yeah. So these, if you look at the Dig Octa, we now have 2 switches, and these are double pole, double throw switches. So they basically, this does LED 1 and 2, and this one does LED 3 and 4. They're still the resistor switchers, because that's a unique feature on the Uno and Quad that'll stay basically. But now it'll come shipped in 33R by default, and you don't have the individual switches per channel anymore, but you can switch them per 2 channels. Probably use a thermal switch so the fuse doesn't overheat continually. That makes no sense whatsoever. Yeah, I mean, if you need more than 30 amps, we have the Dig Octa series, which is 50 amps. And then we have the high current version, which goes up to 100 amps. So if you have a large 5 or even 12 volt setup, and you need that much, you just go to a different board, right? I make those too. But power supply wise, at some point you reach a limit where it's probably more efficient to buy more boards and more power supplies than to get one power supply that's bigger, because that'll be more expensive in the end, basically. What? Who's blaming me? What? Kun je wat Nederlands zeggen voor mijn ouders? Ja, ik kan gewoon Nederlands praten. Ik ben wel Brabants, maar dat hoor je meestal niet al te goed. Hoewel je dat misschien op dit moment wel hoort. Maar, ja. I'm gonna take these glasses off, damn it. Was that enough Dutch there, Fonctionnaire? No, that's okay, Greg. That's fine. We're all hanging out here, having a discussion. That's all good. He's speaking in tongues. Oh, no. Okay. How long have we been going? 2 hours. Let's do a final test. Let's disconnect all these wires. And let's do a long data distance test, I guess we should call it. What was that? Your English is better than Dutch. What? What are you saying, Belgian? You're Belgian. I've never heard you talk Dutch or Belgian Dutch, Philip. So I'm just joking. But yeah, they said you speak English so well. You said he's Bravo. You'll want to hear it. He speaks Dutch. Yeah, sure. I've been speaking English my whole life, but I'm from a little town called Schaik, and I lived in Os a lot, and now I live in a little village near Den Bosch. So yeah, I'm a real Brabo, and I can also talk like how the other Dutch people talk the English, but I think they need to try harder, because then it doesn't sound so stom. So yeah. I never know why on television they speak English like they have a hot potato in their mouth. But yes. Okay. I'll stop. Okay, sorry. Oh man, when I hear our politicians speak English on television, I'm like, what is going on? Why does it sound like that? Stop. Make it stop. Okay. Wait, I still needed that. Dutch people speaking French is the best. Mon français est très terrible. Je parle français un petit peu. I think. Ich spreche auch ein bisschen Deutsch. Das ist auch kein Problem. Ja, ik kan natuurlijk gewoon Nederlands. And I speak English. Yeah, I've been in America, especially when I was younger, a few times, and then in the plane they would ask me how long I would be going on vacation in the Netherlands. I'm like, what do you mean? I'm flying back home. Oh, how long have you been living in the Netherlands? No, I'm Dutch. What do you mean? No, I really no. Chinese is something different. That no, I do not speak Chinese. Not even little words or no. Dat is geen Nederlands. Oh, hoezo niet? En dan krijg ik problemen met mijn Nederlands. God. Oh, but I shouldn't start swearing. We're still on YouTube. Does anyone want a muffin? What? What? No, I didn't say that. Witte geit. Yeah. That's the wrong box. Let me get the testers off the desk. We'll do one last will it do 25 meters of data test. And then I think we're going to round off the stream. Nee, dat is waar, Rob. Dutch or Danish? I don't know Danish. Fonctionnaire, in the beginning of the stream, we talked about the differences of the boards and like improvements and changes. It's been a redesign from the ground up, but the form factor has stayed the same. And mostly the features also stay the same, but improvements and small tweaks here and there. Better ESD protection, more memory, more flash, integrated microphone. Yeah, stuff like that. Okay, let's put the board in. Oh wait, I still need to connect the data wire. So let's just go through the whole 25 whatever meters. No, well, yes, just Rod Murray, that is possible, of course, anything's possible. The question is, however, are you willing to pay $200 for that? I don't know, random number. The answer is probably no, because then you'll just build 3 separate setups, which is still cheaper, probably. And that is then the reason it doesn't exist. Yeah, but Chinese different, man. Yes. Chinese something else. If you go to quinled.info and you go to cable, I have, I think, premium cable or something like that listed, and you can find a listing from Oxmer actually, which has this 16 and 18 gauge 3-wire bundled cable, and in my opinion it's pretty good. Okay, you guys couldn't even see what I was doing, sorry. Okay, let's put the ESP on there. There. So this is all linked together. Good. Let's take another Wago. Ow. This Wago sucks. Ow. Yeah, this Wago is going in the trash. Don't I have any better? Oh, I have some better ones here. There, this one's better. Okay, we need some LED strip. Let's, I don't know. Let's take some Queen LED strip. They're quite stiff, yes. Yeah, so a separate cable like that I wouldn't recommend. Then I'd recommend buying two wires. So you run power, like 12 gauge red and black for positive and negative, and then you run data and ground again for your data wire. So still a 2-wire, because otherwise your data could be uncoupled too much, and that over distance can create issues. Where did I put it? Oh, here. Okay, let's connect to our bench power supply. There. Yes, correct. You then connect grounds together near the strip, and then it should work great. Fake Wago, yes. Generally, they're pretty good. Some are not that great, but then it would be best to maybe twist it around the power cable so it's tightly linked to the positive and negative wire, because that couples together, and especially in 33R mode helps the data get further. Exactly, Big Red Frog. That is often a solution to that issue. Okay. Let's take this one out. Let's see. Red. Here we also have red. And here we also have red. Oh! Good, I checked. Ground? Not ground. Oops. You guys almost had smoke. Now, ground and data mixing up isn't too bad. Okay. Go. Oh, wait. It's the bench power supply. It doesn't do anything unless I push buttons. Let's set it to 10 amps. And let's set it to 24 volts. Now go. Nothing happens. I don't know why. The little LED came on, so that is for... I have added blue LEDs for Q1R and also on the ESP itself. Did I remove it from the configuration? Maybe. So let's check. Oh, I don't know. I don't know which one it is. So let me turn this one off. That's not it. Turn this one off. That is it. Okay, good. Configuration, LED preferences. Yeah, so the new GPIOs, because the new ESP32s have new GPIOs, is 2 for LED 1, 4 for LED 2, 12 for LED 3, and 14 for LED 4. So let's change this to 2. This is 160. It is BGR with WG swap. Okay, save. Ah, good. It's generating power. What? No, it's just because of the stupid plug. What's going on there? Okay, never mind. Yeah, let's see if we can do an effect. So all the boards now have audio reactive. So let's go to here. Is it this one? No, this one. Yeah. Well, you can do this one. Hello. That works great. Nice. And this is running, you saw me connected. This is running all through this bundled up cable here on my disk. Yeah, so Greg, I have thought about that. I did a live stream about that, but it's basically vendor A talking about controllers of vendor B, C, and D. And even though I would mainly have technical arguments, it's still, you know, I don't want to be that guy. I guess if I wasn't making and selling my own products, I'd probably do that. But because I don't, or because I do, it would always be seen as bad mouthing another product to promote my own. And I'd rather other people do that and then promote mine because of technical excellence or whatever, instead of me doing that, saying, look, mine's better, haha, all other controllers are crap. No, I don't think that would go over too well. Exactly, Philip. Yeah. So let's check the thermal camera. We still have it running. Okay, so the ESP gets warm. That's obvious. There's a little diode on there that's always going to be warm. That's fine. We have our little voltage converter here, or a new one that's also running 40 degrees. That's fine. Yeah, that's always going to do that. That's perfectly fine. This is basically doing nothing. Yep. Shielded wire. You can use coaxial wire, but then you'll have to adjust the resistors. But if you connect the shield to ground and then use the middle coaxial wire for data, in theory that works. I actually wanted to do something else. I forgot. Let's turn this off. Let's disconnect this. Yeah. Because I want to show you how well the sound reactive stuff works. If I can make enough room on my desk. Maybe. There. Yeah, okay. Maybe not. Well, this can go here. No, it can't. How am I going to do this? No, it can't. I have a wire. Okay, so let me connect these. The other strip was WS2814 at 24 volt, my custom Queen LED strip. This is 5 volt. So let's set that to 5 volt. Okay. Yeah, let's power it up. Okay. The colors are configured wrongly. I want to try and get this all on the screen. Let me turn off a lot of this stuff. There. And now I need to change the LED preferences here to 144. Still SK6812, but then we have, I think, RGB with no swap. Not sure. No, it's green. That's wrong. Do we have RBG? No, that's pink. Is it GRB? That is orange. Good. Oh, wait. And then I want sound react. Let's put this up high. I need to configure something real quick. Okay. Effects. This guy. Sound stuff. And I want frequency wave, I think. Yeah, and I want to max out the speed. And now I need to adjust the camera. Because that can create some really cool effects. Oh, it doesn't know where to focus now. Damn it. Oh, wait. Let me change the focus. That's the wrong button. Okay, let's hope that's better. I don't know. A little bit less. Yeah. And now let's see if I can play a song. Let's stop the music here. Music. I guess I need to have a royalty-free song, huh? Where do I find those? In my OBS folder? Music? Yes. I don't know. I'm just gonna wait. I need to change my audio device. Maybe that is gonna break the stream. I don't know. Let's see. Yeah. Okay. So now it's reacting to my intro song. I can play with the values a little bit. We're not 60 FPSing anymore. I don't know why. Oh, there we are. Okay. Yeah, anyway, I thought it'd be funny to show you the sound reactive effects. Let me change it back to my headphones. No, wait, let me just kill this one. Okay. But I'd say that works quite well. It's very responsive and fluid. I like that a lot. Where's the music? Here it is. I guess we're going to have the same song here now too. Yeah. I hit the button like a zillion times. I don't know what song we're getting. That's fine. Yeah, but this is a 5-volt SK6812 144 LEDs per meter strip. That is running through 25 meters of cable, including power. Now, you can't get a lot of power through there. We just saw that with the fusions and stuff. But the data signal is perfectly fine with the new D-Quad. So, yeah. Anyway. Okay, I think the thermal camera can now retire a little bit. I'm glad the battery lasts, like, I always thought, like, why do I need, like, 8 hours of battery life on my thermal camera? Well, now I know, because the Wi-Fi is so shit to connect. Once it's connected, because then I emailed support and they said, oh, your Wi-Fi is probably cutting in and out, and it's your router's problem, and your No, if I can connect for 4 hours straight without it dropping once with a live video feed, it makes no sense that I just can't connect the first time, okay? Ah! The Wi-Fi is fine. Yeah. Yeah, we talked about that a bit earlier, Philip. So the new one indeed only has 2 switches instead of 4, because the switches share 2 channels. But because most people will set it to 33R mode anyway, yeah, I didn't really see an issue with that. And the other modes are still there. Yeah, you just can't switch it per channel anymore, but it's per two channels. Yeah, no worries, no worries. You need a software update for the camera. Yeah, I don't know why. Sometimes it goes to less than 60 frames per second, but I've never been able to figure out what's causing that. So yeah, I don't know. Nice, you still have a V1. Awesome. Can you explain how the fast blow system works electronically? Well, it's not electronic, it's thermal. So fuses are thermal devices, and a fast blow or a slow blow fuse basically means how much thermal load or continuous load it can take before blowing. And a fast blow fuse will blow quicker than a slow blow fuse if they're both 10 amps. Basically, a slow blow fuse can sustain a higher load than it's rated longer than a fast blow fuse. And in this case, if it goes above 10 amps or 5 amps in our LED load stuff, we basically want it to blow pretty quickly, because then it's a weird scenario where that shouldn't happen, right? So yeah. Malachi says, thanks for another amazing live stream, Quinder. Well, thank you for watching. Yeah, so the board basically has a diode per channel on there that if a short happens, it'll also short through the diode on the board itself, trying to generate a higher current on the board already, instead of making that go to the device or where the short is and back, to blow the fuse quicker. That's basically the idea. But all my boards have had that for years, right? That's my own circuit. Yeah, so it has some extra short circuit protection. I call it short circuit protection, but it's short circuit quicker blow. But yeah. I don't think other boards have had that, except maybe some other vendors who've now copied that. No, that's not new. No, it's been on there, maybe on the V1 already, but at least on V2 and V3. So yeah, and the Uno, the Quad, the Octa, the Dignex, etc., they all have it. I've been doing that for years on all my controllers, just to make it more safe, right? If there's an issue, better blow the fuse quickly and try and protect whatever is connected, than cause an issue with everything that's connected, because that's now also seeing the short. So if I can minimize the loop of the short by having it on the board itself, well, that's the best. Yeah, I did that. My circuits have been quite unique since the start, and I put a lot of thought and effort into that. So that's been a while on there, yeah. Awesome you were here, Foxionaire. Always appreciate it. Yeah, we've almost... Oh, okay. We've been going 2 hours and 40 minutes. That's pretty good. So next week I won't be here, so there won't be a live stream, and maybe I'll do a live stream. I'll be at a different location, so I don't think I'll do a live stream. Maybe we can do some sort of hangout and talking through the phone. I don't know how that works, but maybe, or maybe there will be a video, but I don't think so, because I haven't had time to prepare one because of all kinds of other stuff going on. So maybe next week there will be nothing. I don't know. We'll see. Discord chat's always there. No problem. You've almost all the versions. Nice. I am a Big Red Frog. I am working on some ESP32 P4 designs, but there's a hardware-software problem there, that even if I make the hardware, the software isn't quite ready for it. Yeah, but I will be working on some P4 designs, which might still release this year, but my deadlines have all been pushed back again, etc. Right now I'm cramming to get this stuff out, because that's most important right now. I want to have a very nice upgrade this year. And, well, I guess I can share a secret. They will be more expensive. Because, yeah, prices have been rising for the past year already, but recently it's been really bad. My PCB costs have gone up between 25 and 50%, just the raw PCBs. My assembly costs have gone up 15 to 20%. And some components, on the new boards, I selected a component in November. I could get plenty quantity and it was 30 cents. And now that same component is hard to get and it's about $1 a piece. So it tripled in price. And, well, I could redesign everything again. It'll take another few months of testing and validating and blah, blah, blah. And then it might just happen again with that different IC. So I haven't raised prices in many years. I don't know, 2-3 years already. But on the back end, stuff has been rising. Partially right now is because of the wars, because resources are scarce, and because of AI. And you think AI doesn't use ESP32s. No, it doesn't use ESP32s, but it does use PCBs, and the raw material for PCBs and like gold plating and all kinds of stuff is also a constrained resource. And if it's all going to AI, everyone else who wants to have it is just going to pay more because the AI guys have, for whatever reason, they think an unlimited budget. So they just keep raising the prices of everything so they get it. But then that means that for other people, everything also gets more expensive because, they're willing to pay more, or supposedly, because that's fake money, but sure. So now you also have to pay more. That's basically what's going on. Because there's only so much resource, right? And if they claim it all, yeah. So my prices on the back end have been growing steadily over the past few years. And the new boards, for instance, feature a new ESP32 module, which is smaller and has more flash and PS RAM. I think that's going to be important going towards the future because the 4 megabyte modules currently are a constraint for lots of software out there. Like Moonlight already has problems fitting into that. WLED, you have to disable features to get it running into that, etc., etc. That's why there's so many builds, because they're very much memory and flash storage constrained. So all the new boards, like the Dig Next and these upgrades, will have 8 megabytes of flash and more RAM. But that, of course, also costs more. And some ICs on there are a little bit more expensive, or because I use better ones. All the extra protection costs extra money. Yeah, so I see the current ones already are hit with the price increase, but I'm still eating eating it for those. So my margins just get less and less, and they weren't high to start with. But the new boards will be the threshold where I will have to do some price increases, which I hate. People who know me and who've talked to me for years, they know I hate that. But at some point, I won't make any profit on it anymore, and then the business also isn't sustainable, which would be bad for the business, right? I mean, I don't care personally too much as long as I can make a decent living, but I can't go negative. Yeah, 4096 pixel with 60 FPS. An ESP32P4 will do that easily. An ESP32 normal will have issues above 2000. It'll be around 40 FPS-ish, something like that. Depends a bit on the effect and things like that. But also on the code you're running. If you're running fast LED, for instance, with Moonlight, you can probably squeeze out more performance, like 3000 LEDs. But with WLED is pretty heavy. So 1500, 2000 LEDs, you can stay around the 40, 50 FPS, generally speaking. Yeah, but a new ESP will definitely help for that. But also more expensive. Hey, Philip, thanks. That is very much appreciated. Thank you very much. Negative margin. Yeah, negative margin bad. Well, no, it'll be an increase per board, and per board I'm going to look at like maybe $2.5, $3 increase, because that's basically what my costs have also risen. On the new boards I need to see, because the costs have risen, but also the different components and things like that, so I need to see what I can do there. But yeah, there's not too much I can do about that. Right, okay, yeah, sure. Big Red Frog, I can imagine, yeah. Yeah, so I guess that's the secret for today. Great new boards, all tests, including lots of power testing, little bit of data testing. Great, zero issues. Even blew some fuses, no problem. We all did it with the same board, by the way. This is the board we stressed and blew the fuses on. No damage, no issues, all working great. So that's awesome. No, I don't think it'll be $5. I think it'll be like $2.50, $3, something like that per board, and it depends on the version. But yeah, and I mean, like this little Ethernet guy, it's now a 6-layer board. It's hard to assemble and solder together because it involves a manual parts and things like that. And there's lots of components on there. Yeah, making things compactor and more advanced just costs more money. Yeah, but I think it's good to move to a single board here. Also for like certifications and things like that. So yeah. Well, by now, if you need them, if you know you're going to need them, the old versions or the current versions, they're not really old yet because this hasn't been released, will stay as they are, but at some point we'll stop making them and they run out, and then it's the new version for the new price. Yeah. Could this single board be used with DIG Quad 3.5? Yes, the Ethernet board. Yeah, no problem, no problem. It'll work on the current DIG Uno Quad boards exactly the same. Yeah, just the pinout's different. The GPIOs are different, but the pins are the same. So that'll work, no problem. The AN Penta also fine, no problem. Oh, actually, I didn't. I'll have to check that one. I'll have to check the AN Penta. I'm not 100% sure about that. Because of the Ethernet, yeah, in theory it should work, but I'll have to check that. No way to avoid the manual part. No. Then I'd have to change the form factor of the board, and I don't want to do that. But basically, the components are just too close together to do certain types of soldering. I'm still looking to maybe do it differently, but if you look at this board, wait. If you look at this board, especially the part over here, you might think there's still some room there where you could move stuff, but you also need traces at some point at some places. And those are already 0402s. I could go even smaller, but then assembly also becomes more expensive. And it's just all jam-packed together on there. It works great, that's not a problem, but yeah, the assembly is just difficult. Yes, we also sell the ESP separately. Yeah, I have some live streams and videos, but there's also an article about PUE and why basically it doesn't really make sense with LEDs or integrated into the controller, because then it would have to be even bigger. And because of having PUE on there, even a DIG Quad would have to be bigger to have the circuitry on there, especially if you want to drive LEDs with it. And you need better other different heat management, and you'd basically be adding like $15 to $20 of circuitry to the board, which then a lot of people don't use, which doesn't make sense, and making it modular is a whole kinds of mess on its own. So just use a PUE extractor. You can get those cheaper than I can make the circuit on the board. And you just put the PUE extractor on the PUE cable, and then put the Ethernet cable in and the power cables in, and done. And yeah, there's a lot of talk always about PUE, but get a PUE extractor. Done. Later, Emil. Yeah, but I'll make a special point of selling the new boards without an ESP for a limited time probably, and also sell the ESP32 separately forever. We already do that for people who want to use them in their own projects. Yeah, that we already do. Yes, no problem. 101 Tesla. Yeah. So on a DIG quad, you then connect the PoE extractor to the it used to be called 5-volt EXT, but to the VEXT connector here, and then also your relay to those connectors. Those have a new circuit. They don't use a level shifter anymore, so no more fifth secret channel. But they now use a load switch. And then you have your main power supply connected to the main terminals. And then your board will stay online with the PoE power, like 5 or 12 volt, from the extractor. And you can switch the main power supply using the relay. No problem. So yeah, you can use your PoE for standby power. That's fine. But then buy a $5 PoE extractor, done. You're pushing me to the 3-hour mark again. Yeah, so you don't need a separate power supply then. You use the PoE with the PoE extractor for that. For VEXT, perfect. Yeah. An IP68 version of the DIG cob for pool, ponds, waterfalls, and things like that. Whoa. I haven't thought about that, no. I'm not sure how large the market would be for that, because I'm not like a big company like the others, so I can't just make all kinds of versions and in all kinds of color, temperatures, and etc., because that's a lot of capital for me. Like, if I have to make a batch of 1,000 strips, I'm out like $25,000, right? And I need to pay those $25,000, and then I get strips for that, but now I have strips and no money. So I can only do so much, right? The price for the board, you mean the ESP? I don't know yet. Probably around the same price, but maybe $1 or $2 more. I don't know. Use the legacy connector. Yeah, the legacy connector. I'd have to verify that. Ask me on the Discord. I'd have to check. Oh, shipping is slow. Okay. Huh. Having different amounts of RAM/ROM available could be a solution to reduce cost? No, because then you'd have to use a different module, and that's going to introduce all kinds of other issues and multiple firmwares, and it's going to create a lot of headaches. Because then we also have to stock those multiple versions, so it ties up capital again. And every version extra we make, we have to make a quantity of to have in stock and at our resellers, and it's more complicated than you think. You're waiting to close the stream so you can check and manage your EV charger. Okay. Bright red light. Oops. Well, Philip said it's done, so it's done. Thanks for watching, everyone. As I said, next week we probably won't have anything, but then I'll be back the week after that. And don't hold your purchase for these boards. It'll be months before these become for sale, and then we'll still also have the old version because there's nothing wrong with them. But yeah. Thanks for watching, and leave a comment. Come to the Discord server. We're always there, happy to chat. And yeah, see you guys later. Bye-bye.